Hey guys, welcome back to this tutorial. So in this tutorial we're going to be working with the exam scores file, and it's a CSV file. So we're going to be using the pd.read CSV function. So I'm creating a variable named df for that, and using what we've learned so far, let's check the head of our data frame to see what it looks like. And here we have a gender column, we have a race ethnicity column, parental level of education, the lunch, test preparation course, the math score, the reading score, and the writing score. Yeah, so that's awesome. So let's proceed and check the shape to know exactly the number of rows and columns we're working with. So I'll just say df.shape. Yeah, so we have 1000 rows and we have 9 columns. Yeah, so we have 1000 rows and 9 columns, and this first column seems to be just a serial number or just an index, so we can just remove it since it's irrelevant. It's just a serial number. If you check the tail, you'll see that it corresponds with this index. Let's check the tail, and yes, you see it's the same thing as the index. So let's just remove this. Let me change this back to the head, and let's remove the first column. Remember, we learned ways by which we can remove columns from our data frame. You can try this on your own, otherwise you can just follow up. You can use the delete function and just say df and just recall the column. And here we want to just remove the first column, that's the unnamed O. Am I right? Let's check so we don't delete the wrong column. Yes, unnamed O, that is the name of the column. So let's just run this, and then let's look at our df shape again. And yes, we have eight columns now. So if you check the head again now, we wouldn't find that first column there again. Yeah, so we are just left with our data as the first column now, and this is pretty cool. So let's check. So here we seem to have a lot of categorical variables here. So you see we have gender, we have race, and all of these are categorical variables. We have just 3 numerical variables here. So let's take a descriptive statistic. Let's say df dot, remember the function to use, that's the describe function, and let's see what we have. Yeah, so remember the describe function always it only gives the statistical summary of numerical variables only, and since we have 3 numerical variables, that's why we're having just 3 columns being returned for the describe functions. So let's just see, we have the count for the math score to be 1000. So here with the reading score seems to be the highest average. So we have the reading score to be 70, math score 67, writing score 68.9. Standard deviation is this. We have the minimum value 15, 18, and 10. We have the 25th percentile, the 50th percentile, 75th percentile, and the maximum value. So the maximum value is 100 for all. Wow. So we have students that scored 100%. Wow, that's awesome. So let me just quickly take you through what this 50 percentile means. Usually when you check your 50th percentile, that is the median, it shouldn't be far away from the mean. When the median value is too high, or too low from the mean value, it means you have outliers in your data set. What do I mean by outliers? Outliers means, let's say you have a data of 1, or let's say 2, 3, 4, 3, 4, 2, 5, 6, like that. Then you now have 100, and you now have, let's say, 200 here. You know, when you look at this data set, if you would calculate the median, you know, median is calculated by rearranging the data. Let's rearrange this. Let's say you have 2, 2, 3, 3, 3, 4, 4, 5, and then you have 100, and you have 200. If you calculate the median here now, let's say you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That will be in the middle. So we'll say 1, 2, 3, 4, 5. This 3 here, and then we count here to 1, 2, 3, 4, 5. So we'll say 3 plus 4, that is 7, divided by 2. So our median will be in between these 3 and 4, that is 3.5. So our median for this would be 3.5. But if you calculate the mean, then let's convert this to a list now. My list, I just want you to understand how outliers affect. And then let's this out. And then let's say let's convert this to a numpy array dot my list. And then let's just say print array dot median, and then print array dot mean. I hope it works this way, or we just simply need to, yeah, oh, numpy array has no median, yeah. Okay, let's see the mean. Yes, so there is no median function in numpy. So, but we've calculated our median, and it's 3.5. Now see that we have median of 3.5 and we have the mean of 32.6. So you see that this is too, the difference is too much, and it indicates that we have outliers in the data set. So that's just what the median and the mean, that is one thing, the one insight you'll be able to derive from your descriptive statistics when you're working with numerical data. Just keep it in mind and understand how this differs. So when you have a difference, when you have too much difference between your median and your mean, it's just one single thing, is just that it indicates that you have outliers in your data set, and outliers are toxic in data analysis because they create noises. They will not let you establish the right insight. So usually we want to get rid of outliers in our data set. So we'll look at how we can deal with that in the future. But for now, I just want to show you how you can make inferences from your descriptive statistics. So let's go back to our describe function and look at other things. So here our median and our mean are not really different. So it means that we don't have outliers in our data set. So the data is pretty much clean. That is what it means. So that is just one thing to derive from here. So we can also do what we call conditional selection. Conditional selection. So conditional selection in Pandas is just when you want to select a particular group or a particular data in your data frame. So let's say you want to select, you want to have the data of those that scored above 50% in their math score only. If you say DF score greater than 50, so you see we have true, and you have false here. But so this is, it will just return a Boolean series for you. So if you want to filter it in the actual sense, you need to pass it in the DF. So you simply just say DF, then you pass this in. So this is just like you are passing this true. You are passing it in the data frame. So this is what we call conditional selection. So if you execute this now, you would have the actual values and not just this true. So it will filter out all that scored less than. So you see now, initially we had 1000 rows. So you see now we have 875 rows. So we have filtered out those that scored lesser than 50. We can increase this to, let's say, 70, and you see how much it would be reduced. So you see we have 417 rows now. So that is conditional selection in Pandas. So you can use any of the columns to select. You can also use AND. You can say you want to select those that scored greater than 70 and in maths, and also greater than 70 in their writing score, in their writing. So this will not just be limited to just maths. So it will be those that scored greater than 70 in maths and those that scored greater than 70 in their writing score. So you see we have 343 rows now. So all of these, you see their values. We have 87, 75. So you see that all of these values will be greater than 70 for both math and writing scores. So you can do this for any column that you want. You can filter out values and select the particular ones you want using this conditional selection. So that is just that about conditional selection. We'll talk more about data wrangling in the next tutorial. Thank you.